So basically, we're going to talk a little bit about kind of the reliability of applications and Kubernetes. So 50 years ago, man landed on the moon, and the system that kind of took us there is a lot simpler than the systems that we generally kind of build today. Our kind of job as technical people is to kind of manage complexity. We can kind of divide the kind of this complexity into kind of three main groups. We've got kind of domain complexity, or the problem that we're trying to solve, architectural complexity of how all the kind of components all fit together, and then the operational complexity, essentially running stuff in production and dealing with users. So within kind of these three main areas, there's been obviously a lot of research and a lot of writings around kind of patterns and kind of best practices that you can kind of use to help manage this, to help kind of, understand these complex systems. So within the kind of domain, you've got the object-oriented patterns, or the Gang of Four patterns, domain-driven design, Martin Fowler's book, Patterns of Enterprise Application Architecture, and Bob Martin's Clean Code. For architecture, you can build things using the kind of hexagonal clean architecture. You can build things as microservices, and even the humble monolith can allow you to kind of manage that architectural complexity. And then for operations, you've got kind of the concepts around site reliability engineering, and Michael Nygaard's book Release It, which gives you the patterns of being able to run more reliable systems as the unpredictability that we get within a production environment. So why am I kind of talking about patterns? Essentially, they help us to be able to pattern match and to be able to chunk large kind of complex ideas into smaller, easier kind of nuggets. So you can kind of open a class, for example, and see like, okay, there's a builder pattern in there. If we're working in an object-oriented way, we can look at a collection of kind of services and be like, okay, we're communicating using JSON in a RESTful way, so that we can, like I say, kind of easily understand what's going on within these systems. So in this talk today, I'm going to be talking about how we do that within a kind of distributed system context, and specifically within Kubernetes using containers. So Brendan Burns and David Oppenheimer released this paper in 2016 called Design Patterns for Container-Based Distributed Systems. And then the subsequent book that Brendan Burns put out describes a set of patterns that you can use to design distributed systems, naturally. And what I'm going to be focusing on today is the single node patterns that he's got within there to basically run multiple containers within a Kubernetes pod to augment functionality, as well as improve the reliability of a service without actually touching the main code base of it. So just working with, like I say, kind of the components of a container. So I'm Davy Jones. I work for a company called iZettle. You've probably seen our card readers in a lot of kind of cafes and that around London as you've been here. And essentially our kind of goal is to empower small businesses, that focus on small businesses, to be able to kind of grow and reduce, kind of improve the diversity that we have within the kind of retail space by providing easy access to card payments. We're based in Stockholm and in Edinburgh in Scotland, so I'm based in Edinburgh, and we build a lot of Go services, and we run those on Kubernetes. So just to talk and kind of level set ourselves about reliability, users don't really care how complex our systems are. They don't care how cool our systems are as well. We may find it nerdy and interesting, but generally they need, when they go to our services, it needs to kind of work within a satisfactory kind of tolerance for what they're kind of expecting. This quote by Michael Nygaard, I kind of love it because it just kind of shows the brutality of what a production environment happens. We kind of sit there developing these systems, putting under testing. It's got great unit tests. It's, we feel like we're writing absolutely beautiful code. And as soon as releasing in production, users do what users do, and we then start to see the problems or the things that we missed or the assumptions that we made. And so we need to kind of have a framework around kind of thinking about reliability. And you've probably all seen or heard of Maslow's hierarchy of needs that basically says to reach the kind of pinnacle of human existence, as Maslow defines it, which is self-actualization, you need to have the needs underneath satisfied. So, our physiological needs, we can't be, having good creative thoughts if we're hungry, we haven't slept, or we're not breathing. Mikey Dickerson, who was an engineering manager or an SRE manager at Google, came up with the idea of the hierarchy of reliability, which essentially says that we can't have good user experience or a good development practice without monitoring being the thing that underpins everything. Within SRE, within site reliability engineering, there's a core concept of a service level objective, which essentially says for our service, I will strive to deliver a set kind of experience for our users. An example of a SLO or a service level objective would be that my service won't return an error for 90% of the time. So that's essentially saying that I'm going to have 90% of my requests be error-free. But that then gives me the other side, 10% of requests that can have an error, which then gives us our error budget. An error budget is one of the kind of core things around SRE, but also allows us to have unreliability in our services, because essentially distributed systems are always kind of failing, just by the nature of it, as we heard in Bone's talk earlier around the fallacies of distributed systems, fallacies of systems in that the network is reliable. The network is never reliable. And so to be able to have a service level objective, we need to have monitoring in there so that we can alert on those things. And then when we do get an alert, we need to have good, mature incident response practices and then post-mortems to learn from everything. And those three kind of bottom layers are incredibly important. So obviously, there's a lot of books and readings that are definitely worth checking out. Release it's now in its second version that was released a month ago. That's got a lot more information around kind of microservice architectures. There's a link to the slides there. I'll have there's a load of links at the end of here as well, and I'll also put that link up later. So who's running Kubernetes in a production environment? Okay, sweet. So I'll quickly kind of run over the level setting of what Kubernetes actually is. Essentially, it's a distributed system that allows you to run containerized workloads. And the main unit of deployment within Kubernetes is the pod, which is just a group of one or more containers that share a storage and a network. So you can, within the kind of Linux namespace concept, it's sharing the mount and network namespaces so that you can communicate over localhost and you can mount a volume to multiple containers and you can read and write to it. You can define configuration using config maps, and this can be in the form of a file that you can mount or environment variables and secrets or encrypted versions of config maps. Services define a logical set of pods, so you can think of it sort of like a load balancer to a degree. Essentially adds a separation between your services, and it'll have a virtual IP for routing to it. A lot of times it will have a DNS name that's routable to it. If we're getting access externally, then we can use ingress controllers, and this can kind of provide layer 7 path-based routing to it. So our fancy gopher there can basically want to go to the root of fancy, and it will be then routed to the right service that's defined by its ingress object that's then known by the ingress controller. And then there's obviously a load of other components, but one of the other kind of interesting things that we can do with it is we can define custom resource definitions to extend Kubernetes so that we can add other parts to it. For example, the cert manager, which used to be called kubelego, allows you for doing automated certificate provisioning. And then we can also wrap up, so what CoreOS defined the operator pattern, which allows us to take the operational requirements for a service and wrap that up within an API so that we can automate stuff. The Prometheus operator is an example of that, which allows quite easy configuration of Prometheus using APIs. So essentially what we're going to be doing today is taking an application that's inherently unreliable and making it more reliable by adding extra functionality to it using other containers. So essentially the service here is a front end that then talks to a back end. And if we have a look at our service, it's basically this little thing. And essentially it provides nice messages. So we all like to have like to feel good about ourselves. So I think I've got pretty good style. Okay, yeah. But the problem is it's not the most reliable. So every X amount of requests, we're getting failures come back to us. And obviously, this is Buffalo running in development mode, so this is really obvious what's kind of going on. Don't run Buffalo in development mode in production, but for the sake of this demo, it gives us a nice, really obvious error message. So essentially, that's that, and then we can use some patterns to improve it. And so this is, seeing a lot of people obviously using Kubernetes. So it's defined by YAML files, which isn't the most interesting of things. But essentially, this specification here, on the left, we've got a deployment, which is deploying one pod that's got one container in it. And that's the awesome core feelgood API. And that's exposing a port of 8080, which we're then on the right using a service to map that to port 80, so that we can then use the front end to call into that to using its DNS name. So pretty much the same setup here. The only slight difference with this one is there is a config map attached to it, which defines some configuration. So we can see in the API address there, we're just using the cluster DNS name for it. So here are the kind of three main patterns that I'm going to be using today. The sidecar pattern, the adapter, and the ambassador. So first things first, sidecar. We're going to use a proxy sidecar. We're going to use HA proxy to do that. Reason is because it's off the shelf. Version 2 exposes metrics over Prometheus, in the Prometheus format, so we can scrape that. And it's, pretty battle tested. So we can basically release the API and the front end with the proxy in front of it, and then set up a service monitor, which is part of the Prometheus operator, to then scrape an endpoint from our service and then give us some metrics. So let's just have a quick look at what that manifest looks like. So this is going to be the same for both the API and the front end. So in here, we've got another deployment. This in here then has got our original container as well as our proxy in it. And we've got a really simple HA proxy configuration that defines a single backend, as well as doing the bits that we need to get the stats out on the Prometheus format. So cool. So with that applied, now, little spoiler, I've actually already deployed this thing because it takes a little bit of time for the Prometheus operator to get the new configuration, so I don't want to stand like a bit of an idiot. So essentially, this has already been deployed for the API and for the front end. And then essentially, if we have a look at some metrics of that, I've got a Grafana dashboard here, which hopefully y'all can see at the back as well. That's then got ourselves some stuff, some requests going in here that we can see. The requests coming in, we've got basically for metrics, I'm using the RED methodology, or RED pattern, I suppose, of request rate, error rate, and duration. So those are the kind of three main metrics that I can use to help define our kind of SLO for it. And what we've got is basically saying our service level objective over 5 minutes. For our error rate, I'm allowed 10%. So I'm allowed 90% of my requests should be okay. But obviously, our actual error rate is about 25%. What I'm going to do is I'm just going to start up a load, create some load on the service. That's just using Hey, which is a load generating tool. And so this will generate us some more traffic within our system here. And then we should start to see, we'll see our error rate kind of start to kind of skyrocket as well. So essentially, we've got a bit of a problem, but we don't really know where it's coming from, mainly because there's no logs coming out of this service. So that then leads us on to our kind of second pattern, which is the log adapter, or the adapter pattern. So the adapter pattern obviously isn't just for containers. You can use it for, it's one of the 24 gang of 4 patterns. But essentially, as the name suggests, it adapts one format into another. So Kubernetes wants to have its logs come in standard out, but our API is actually logging to a file. So we need to have the adapter take the file format and put it out to standard out. And then once it's in standard out, you can then use things, something like FluentD or Logstash to be able to then take that, that output format, do some other enriching of it if it needs to, or another adaptation to then be able to put it into something like Elasticsearch. So you can now get metric data from the proxy, from Prometheus, and your event data from your logs. So let's just go into that and deploy it. So yeah, so essentially what I'm going to do here is, can you see that at the back? I'll zoom in a wee bit. Right, so I've got kubectl mapped to K because I'm a bad typer. So I'm going to get some logs out of our fieldGet API. We can see here that obviously we've got 2 containers running, so I need to specify which container I want. So it's going to be a fieldGet one, no logs there, fine. Let's apply this. This is now deployed another container within our things. We've got 3 running in our API now, which is the actual app, our logger now, which is doing some really complicated stuff of tail-effing a log file, and our proxy, which is now obviously handling our ingress traffic going into it. Cool, so let's have a look now at our logger container. And now we've got a ton of log files. Good thing that the application developers actually put it into a JSON format, so that makes our lives a bit easier for putting into something like Elasticsearch. But for the sake of this, I'm going to do the classic grepping logs for a 500. Cool. And then I'm going to use JQ to now get the response out of it. Right. So here is our error message. Essentially, a random number is divisible by 3. So I don't know if this is a bug or a feature, but essentially, we can't really be having it for our application. And because we don't have access to the code base, we can't fix it, so we need to find another way of handling that. And that leads us on to our kind of next pattern, which is the ambassador pattern. Now, similar to an ambassador that will kind of go out to a nation state to basically say, I want you to go speak to another country for us. I'm not going to. I want to basically do it through the ambassador. We're going to do the same thing here. Essentially, we've got, let's say, Britain and Europe, and we want to use an adapter to go through that to handle our things. And because we're now adopting a circuit breaker within our ambassador, so I'm just making up this analogy, but actually it works really well. So essentially, now our ambassador is implementing the circuit breaker pattern, which I'll explain in just a second. If we don't get the response we want from EU, that's fine. We can just tell our citizens what they want, what we want them to hear. Anyway, so no more politics, sorry. So essentially, a circuit breaker, if anyone's seen them in your homes, you want to stop your house blowing up if you have too much energy within your system. So essentially, this will trip rather than your house blowing up. Similar way, we want to decouple our failure domains within our services so that essentially if we have a situation where our API is seeing some big problems, as we can see, that's kind of the core of where our error rate's originating from. We can essentially trip the breaker, keep it open, and then we can return a kind of canned response back to our front end so that our users will see 200s, or they'll see good data, but it might just be a little stale. So you can use this with caches quite well to essentially reduce the amount of load that you're putting on a service that's not healthy, because essentially it's returning poor data, which means that we've got problems. So we need to kind of reduce the load on it because we essentially start causing a thundering herd problem. And by that, we're kind of decoupling those two kind of failure domains within themselves. So the breaker that I'm using within the example is one that's just written in Go. It's just using HTTP util single host reverse proxy. And because I've got a little bit of time, I'll just kind of show you what that looks like. So essentially within this, we've got basically our canned response that we're going to return as a constant. We've got some metrics coming out of it as well, so this is instrumented with Prometheus as well. And essentially, we just got a handler that any request that goes to it, we're going to essentially pull out the request URI, translate that to what where we want to send it to. So we can basically configure the breaker to go to the feelgood API that we want to. If there's any errors that we get with our breaker, so essentially this part here where we're basically using the Go breaker package from Sony, we're basically saying execute this, but if there is an issue where it breaks the configuration of our breaker, which is essentially if you get any failure, just open the breaker for the sake of the demo. But you could set it to be like if there's 3 requests in the space of 5 minutes, then break. And what it will do is it will basically return the kind of canned response that we get from it, as well as opening up that breaker, and then on the kind of every kind of couple of seconds, it will try again to see if the calling host is back up. If it is, it will close the circuit, and then we're back into to where we want to be. So let's deploy that. Bear in mind, let's just have a look at our kind of metrics to see how bad things really are at the moment before we do release this. So yeah, essentially, obviously, about 34% error rate on both front and back end, causing some problems. So let's go into our last manifest here. So within here, we've got essentially an init container as well that we start up. So essentially, we need the front end to kind of be up in the first case before it starts doing stuff. We could actually probably get rid of that now. That was in the previous deployment because we're essentially now using our breaker within here that we're defining now at the bottom. Also our ambassador that we're defining at the bottom using that breaker image. So let's just apply that. So now we can go back to our front end. There we go. So oh, that's nice. But as we kind of keep going through, our canned response is basically this. So it doesn't matter kind of, what's going on with this. At me as a user, I'm just going to be seeing 200s now. It might not be, in the case of people returning some stale data, may not be obviously the most consistent of things, but at least, we can still use the site and we're not getting on Twitter complaining that your site's down. And then what we'll see on here is we'll start to see this tail off. We can kind of see the error rates are already dropping. So in 5 minutes or so, we won't be breaching our SLO. We'll be under the 10% error rate. And something that's interesting that we will see with this as well is that the request rate for our front end is obviously still going to stay at the level that we're hitting it, but our API is actually going to get less load because we're breaking that circuit. Cool. So those are kind of the 3 kind of main patterns that are defined within the Brendan Burns and David Hobno's paper. And you can do lots of other interesting things with it as well. So something that we've done at iZettle is using configuration sidecars for doing dynamic configuration, so that we can essentially pull something down that's defined from, say, GitHub as an example, to be able to dynamically kind of change the configuration within it rather than doing a redeploy. We can also use queue workers as well. So we still have our RESTful app. So our web app, but we want to fit it within an event source or an event-based architecture. So we can essentially read from the queue, make the HTTP request within the container, and then handle the sending of the queues elsewhere. So essentially, we've got our RESTful app that's been stable. It's been working for quite a while. We've wrangled all the bugs out of it, but we need to add this extra functionality to fit with a newer architecture, a new level of complexity. We can then kind of isolate that within another container. And then the kind of top left one there about data connection ambassador. You could essentially have something that, like PG Bouncer for kind of communicating to different Postgres databases, that can kind of handle that for you. Your app doesn't need to introduce that more complicated logic. Obviously, any kind of talk around kind of sidecars and running multiple containers. Would be remiss without talking about service meshes. So essentially a service mesh is a way to run the sidecar proxy, Envoy in Istio's case, that will handle the communication between services. So as an example here, we basically have the proxy define all the kind of communication will go through that, so we can handle things such as like mutual TLS, add to the kind of tracing telemetry side of things, as well as being able to do interesting stuff. Because you've got the proxy in the way of all the communication, you can start to do things like chaos experiments and start to put faults, inject faults into that kind of request path to kind of injecting your own failure so that you can quickly learn under the kind of experiment conditions. Naturally, service meshes are complicated in themselves, so it's essentially like running another distributed system on top of a distributed system, but definitely have their kind of their use cases, and it's quite an exciting technology. So that's kind of that. Hopefully, we had a look at some patterns. We made a service more reliable by not changing the code, which was kind of hopefully the goal. If we have a look at our error rate here, we're still kind of dropping ourselves down, but it's slowly getting there. Obviously, a lot of these things, like with any kind of pattern, any kind of practice, there's things you can do. Doesn't mean you have to do it. That always kind of comes with a risk. But yeah, hopefully it's an extra kind of tool that you can add to your tool belt. So yeah, slides are there. There's code and there's some extra links after this with all sorts of information, which is super interesting. Well, I find it is anyway. So yeah, that's that. Thank you very much.